Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here. Okay, we've got a lot of ground to cover, so let's just dive right in. Today, we're going on a seriously fascinating journey into the architecture behind intelligent customer assistance chatbots. If you've ever found yourself wondering how modern AI takes this giant, messy pile of raw documents and somehow answers a highly specific user question in literally seconds, well, you are in the exact right place. We are going to break down the actual pipeline that makes the magic happen.
So, let's start with a question we have all definitely asked ourselves. Why is finding specific product information still so incredibly frustrating? You know the feeling, right? You go to a company's website looking for just one tiny detail about a product, and you end up endlessly scrolling through these massive 100-page PDF manuals or clicking through totally irrelevant FAQs. The traditional approach to customer search is frankly super time-consuming and completely lacks sophistication. It relies on exact word matches, and honestly, that just leaves customers frustrated and empty-handed. But as we'll see today, there is a much, much better way.
Here is our roadmap for today. We're going to hit the customer search problem, move right into parsing and text chunking, explore FAISS vector database indexing, look at RAG and Llama integration, and wrap things up with system challenges and limitations. Okay, Section 1, the customer search problem, breaking the traditional mold. And that leads us straight to the overarching solution, which is Retrieval-Augmented Generation, or RAG for short. So what is it? RAG is a framework that retrieves relevant document data and uses it to augment a language model's response, giving you highly accurate answers. Instead of just relying on whatever random facts an AI memorized during its initial training, RAG actually goes into a company's specific files, pulls out the exact facts needed, and uses those facts to generate a contextual, highly accurate answer. Keep this core concept in mind as we trace the journey of a single document through this entire system. Just look at the direct contrast between the old way and the new way. Traditional search relies entirely on keyword matching. It's incredibly time-consuming and, as our sources note, it totally lacks sophistication. Basically, if you don't type the exact right word, it fails. But vector search? Vector search looks for semantic meaning, which enables intelligent information discovery and rapid retrieval. It doesn't just look at the literal letters you typed on your keyboard, it understands the actual intent behind your question. And honestly, this is the entire foundation of our intelligent chatbot architecture.
Moving on to Section 2, parsing and text chunking. This is the ingestion phase.
So, how do we actually get a bunch of PDFs and Word documents ready for an AI to read? First, the system extracts text from multiple document formats, like your standard PDFs, docx, and plain text files, using libraries like PyMuPDF and Python docs. Second, it applies intelligent text cleaning. Because let's face it, real-world documents are messy, right? They've got irregular spacing, weird formatting, the whole shebang. The text extraction function cleans all of this up to ensure a really high-quality output. Finally, in step 3, we spit these massive, newly cleaned texts using an awesome tool called LangChain. Now, let's pause on that third step for a second, because chunking is absolutely crucial here. LangChain's recursive character text splitter segments large documents into smaller, semantically meaningful and coherent chunks. Why does this matter so much? Well, you can't just feed a 500-page manual to an AI model all at once and expect it to quickly zero in on one specific sentence. No way. It would get completely overwhelmed. LangChain basically acts like a highly precise digital slicer, ensuring that each chunk contains coherent information, which directly improves the accuracy of our document retrieval later on.
Section 3, FAISS vector database indexing. Translating to coordinates.
This part is incredibly cool. Once we have our text chunks, we have to translate them. We transform these chunks using a pre-trained Hugging Face model, specifically the All-Mini-LM L6v2, to turn the text into vector representations. Essentially, it takes normal human words and encodes them into semantic meaning. You can think of them as these glowing digital coordinates that capture the actual underlying concept of the text, not just the letters themselves. And finally, those coordinates are indexed inside a FAISS database. So what exactly is FAISS? Well, the FAISS library builds an efficient vector search index, which enables super rapid retrieval from massive document collections. You can really think of FAISS like a hyper-fast, incredibly organized librarian. But instead of organizing books alphabetically by their title, this librarian organizes our digital coordinates by their concept. By creating a FAISS index of our document chunks, the system can almost instantly pull the exact relevant documents in response to a user's query, no matter how huge the underlying document collection is. It's a total game changer. All right, Section 4, RAG and Llama integration, the user query phase.
Let's map out the actual microprocess of a live search happening in real time. It happens in 3 really swift steps. First, the user asks a question of interest through the web user interface. Second, the system immediately translates that question into a vector, and our librarian, FAISS, retrieves the most relevant document chunks based on their semantic similarity. Finally, step 3, those specific chunks are passed right along to the Ollama language model, which acts as the system's brain, generating a highly helpful and perfectly contextual answer for the user. And this brilliantly illustrates exactly where the augmented generation part of RAG actually happens. LangChain's retrieval QA chain feeds the retrieved documents specifically to Ollama LLM. We're using version 3, 8b in this case, to ensure contextually appropriate answers. Listen, the system isn't guessing. It is strictly using the relevant retrieved concepts to formulate its response. This exact integration is what transforms a simple, clunky search tool into an incredibly intelligent customer assistance chatbot. Section 5, System Challenges and Limitations, the grounded reality.
So while this system is undeniably powerful, it's definitely not without its hurdles. First up, document quality. If your documents are packed full of images, complex formatting, or non-standard encoding, the text extraction really suffers and requires a lot of extra pre-processing. Second, scalability. Even though FAISS is ridiculously fast, performance can degrade as the document size increases massively. Third, model accuracy. Getting the absolute best answers might require further training or fine-tuning of the embedding model for really specific domain queries. And fourth, database maintenance. Periodically updating the FAISS index to include new documents can be very resource-intensive for large datasets. So, the crucial takeaway here is that overcoming these scalability and accuracy limits requires deliberate optimization. We absolutely need optimized chunking processes, hierarchical indexing strategies to maintain that blazing speed as the database grows, and continuous fine-tuning of the embedding model. Building an intelligent RAG system isn't just a set-it-and-forget-it task. It requires real, ongoing optimization and maintenance to handle growing document sizes and those really complex customer queries efficiently. I really want to draw your attention to this quote directly from the source material, because honestly, it beautifully summarizes everything we've talked about today. The chatbot responds based on concepts found in the documents indexed in the FAISS vector store. That is the magic of RAG right there. The system works so well because it completely grounds every single answer in its mathematically indexed reality. It combines the deep understanding of NLP, the rapid search of FAISS, and the generation capabilities of Ollama to provide these incredibly accurate, helpful responses. Which leaves us with one final, very provocative question to consider today. Is your company's data actually ready for the RAG revolution? We've seen just how powerful this architecture can be for breaking the mold of traditional, frustrating searches. But remember, it all starts with your raw documents. I really hope this explainer has given you a clear, structured blueprint of how intelligent customer assistance chatbots actually work under the hood. Thank you so much for hanging out with me today, and as always, keep learning.